Hi, everyone. Sorry about the delay. We had some technical difficulties, but that's what happens when you go live. um, and here are we today again with Sebastian Daschner, and he will be talking about, if you can read what's on the screen, best practices for modern Java, enterprise Java projects. So without further ado, let's just turn it over to Sebastian. Welcome, Sebastian. Thank you.
Yeah, thanks a lot as well. And that's now was a very quick and hectic start, because if you prepare a lot of technology behind, video equipment and audio equipment, and then of course in the last minute it doesn't work. So now I'm glad it's working and you can read this here. So yeah, hi and welcome to this Jakarta EE Tech Talk on best practices for enterprise Java projects, especially for modern projects. It's always hard to see what are the current best practices out there, just because Jakarta or Java EE or J2EE has been out there for such a long time. And I go into a lot of enterprise projects and I see a lot of things that could be somewhat improved. And this was the motivation to give this talk, to share a few best practices with you, mostly around how we build projects, how we can basically make the builds more efficient, and how we can, well, make sure that we save a lot of time when we build our projects, so we can develop it with more efficiency and with more joy, ultimately. So my name is Sebastian, born and raised in Munich, Germany, and I work for this company called IBM, and I do a lot of things on enterprise Java. This is my background that I've been in for many, many years. So I do Java EE, Jakarta EE, MicroProfile, enterprise Java in general, and then a lot of things that just enterprise projects would need. And I'm not a big fan of slides, so I think code is more interesting, and I want to share a lot of code and do live coding here for this hour. So what I will show you now is a very, just from the beginning, what are some best practices how to build projects. And another fun fact about me, I like coffee. So I will show some coffee shop example application that we're going to build in a modern way with some best practices in mind. And I will show, well, a lot of tips and tricks how to basically be a little bit more productive, and how we can solve all of these issues in a modern world. So first thing I want to show you, this is a Maven POM XML of a project. You see the project is called Coffee Shop. And now one of the few things that I really, really care about how we build our project is how we start building our Maven or Java artifacts when we build our project, right? So this is built by Maven. You can do very similar things via Gradle if you want, but a few things are important in my eyes. So first of all, if you see the list of dependencies, then you only see two dependencies. That is the Jakarta API and the MicroProfile API. How this works together, well, I will show in a second. But the most important thing for now is that both APIs or both dependencies are provided. That means they will not end up in our deployment artifact. And then what else you can see here is a lot of test dependencies that are all included with this test scope. So that is important. I will talk about testing a little bit later. And then pretty much that's it. So what else we can see is some Maven plugins. And the only reason why I define this is basically because, well, I'm brave enough to use a new recent Java version, actually not the latest version, not 13, but Java 12. And then Maven still has to update their plugins. So if you run the test plugins and the war plugin, it will sometimes fail or issue some warnings. So you manually have to update the version here. Unfortunately, that is not covered yet by the Maven Super POM, so you have to refine just these versions. Other than that, that's pretty much it what I want to have in my projects. So not more, complicated XML. Life is too short to do XML, right? So that is pretty much what we want to include here. And then how I built this project, well, first of all, is, I use Maven on the command line, so I can do things like, Maven clean install, for example, or even simpler, Maven clean package, or only Maven package without the clean phase if you want. I typically issue this build, and then what it will do, it will just build our project. So probably because of this streaming stuff going on. This is a little bit slow. Let's do this again. 4 seconds. It should be a little bit less, like maybe 2 seconds, depending on, well, doesn't get faster, how fast your laptop is. But that's pretty much it. So one of the few things that we want to care about is that our project builds fast. And this is thanks to the fact that we don't include a lot of plugins or lifecycle things into Maven. If I build the project, it should build quickly. When it comes to testing, we gonna go back for that in a second. And now the question is, if I build this here, then I have a thin WAR file, a thin deployment artifact, and now I have to deploy this somehow, right? So there are many, many ways how to do that. We have to get some runtime that supports Jakarta and MicroProfile here. What I will include is I use OpenLiberty to run this project. You could use any server of your choice. And I run this locally and also in production using Docker containers. So here's my Docker file, and that is already an interesting thing for a best practice. I want the Docker file also to be simple and easy. Now, you might ask yourself, okay, there are some other technologies out there where I'm not required to write a Docker file in order to build a Docker image. There's some other Maven plugins out there, for example, but the reason why I typically just write a simple Docker file is, well, if you're in plain EE, this is, really easy, 3 lines of code, not more, and it won't get much more complex than that, because I include a base image that already includes my runtime and a JDK or JRE, in my case, Java 12 here with OpenLiberty. Then I might add some optional server configuration and, of course, my thin deployment artifact. That's it. That's all that it's included here. And the reason why I built this via Docker is just, firing that up on the command line is a very, very simple way. So I can say something like coffee shop temp, and it builds it. And oh yes, I still have to write the server XML. It's a good point. It's another thing that I wanted to show you from scratch. So I don't want to include too much out of the box for you, so I can code this just live. What I need in order to run this with Liberty is the server XML configuration, and that is basically just telling the runtime which features to include. Now, that is a little bit of an optimization thing if you want, because we could just go and say, our runtime supports the Jakarta API and MicroProfile, and I could just include these two. So for example, I can say a server that is called feature manager feature. So for example, this still called Java EE here, Java EE 8, and then MicroProfile. Or I'd say, and this is now a little bit of an optimization, if I know that my runtime, that my project for now only includes, for example, JAX-RS and maybe JSON-B and maybe CDI, then I can just write these individually and just specifying the features that I want. It's a little bit of question whether you care about it. The benefit you get is that this then starts up a little bit faster because the OSGI modules don't have to load everything that's included in Jakarta and MicroProfile, but only what you need. But that's a little bit of a question of a taste. And then you can build this. And now, again, the reason why I built this on the command line just by issuing Docker build and nothing else is, it builds very quickly and it's very easy. I just need a Docker file and then these Docker commands. So that is one takeaway. I don't want to overuse the tool usage here, mostly regarding Maven. This is what I see a lot in projects. You have POM XMLs with a few thousand lines of code and then some plugins that build your Docker images and things like that. And ultimately, from my experience, you spend more time actually configuring these things here in the POM XML to get just the right image that you want. If you could just, write 3 lines of code here and then fire up Docker build, push the image if you want to build it locally, and that's it. So for me, that's actually the easiest way and also the fastest way to build a Docker image, right? I mean, if I again call Maven package, if I want to rebuild that WAR file, and then I just issue the Docker build again, and then I'm done, right? You don't get much faster than this. So I think this makes sense. Now let's finally order some coffee. Let's finally run this example here. So what I have is my example application which I want to show you via HTTP and REST. So if you're familiar with EE APIs, this is JAX REST. If you're familiar with the Spring world, this is very much like Spring REST controllers. So we have something like an HTTP resource that will be available via the URL/orders, and then represented in a JSON format, we can have some, coffee orders. We can get some orders, we can post some orders to order some coffee, and so on and so forth. And then we can basically run this example. Now, I could run this just by running this Docker image, by running a container from the Docker image. So for example, if I run this via Docker run and say, I think I called it coffee shop temp, then I could just fire this up, and then this starts my runtime, right? Super easy. But also what I want to show you, let me show you this quickly, is that we have a few more optimized approaches to do this. And as another best practice, what I want to show you is basically how to be a little bit more efficient with your runtime, curl localhost. If, for example, now I go to my coffee shop project, I can check out the orders, right? So once that is deployed, I see, okay, what are my coffee orders in the system? So this is an empty JSON array because, well, there is no order yet. So if we would create some order by posting a JSON here with, well, what do we need? So already, if you're familiar with the APIs, you see, okay, this includes bean validation into JAX RS. This is just a nice story of Java EE or Jakarta EE that you can have these specs being interoperable. So you can just mix and match these specifications. And now for our example, we need to include a coffee type, like a drink type. So for example, we want to post some espresso here. So then we create this espresso order, and then hopefully, yes, the order is in the system. This looks good. Okay, anyway, now we created some order here that is a very basic Hello World example using JAX RS, CDI, and JSON-B. But, well, now a little bit more about the development workflow here, right? Because what happens if we would like to change something here, then, well, we would need to rebuild, and especially we would need to restart the runtime. And even if we have a runtime that starts up very, very quickly, and that is actually another good news, despite the, common knowledge out there, modern Jakarta or EE runtimes are very, very fast. Thanks to techniques such as OSGI and modern approaches, how to build up a modular runtime, you have servers that start up, in seconds. You don't have to wait half an hour anymore for heavyweight runtime. So this is very good news. But still, it's a little bit too slow if we always, just change some code. I would like to test it out, because then we would need to rebuild our project and then just restart the container or however we run it, right? So another approach, what I want to show you, and this is just for the example for OpenLiberty, is you might want to build up an approach where you can minimize that turnaround time. And what I want to show you is a Maven plugin that adds basically the support for a development mode for Liberty. Now, what I said before is don't overuse the Maven usage. So what is this plugin doing here, right? But in this case, I say, okay, just for the development workflow, it has a benefit, this plugin, and luckily it doesn't slow down my build, because in the normal phase Maven package, this is not executed. This doesn't do anything, which is good. So in my case, what I can do, let's stop this Docker container again. If I say I include now Maven package Liberty dev, which is a development mode for OpenLiberty, then this will start up OpenLiberty in a development mode where it just will watch for my file changes and then do a very quick hot reload. So there are a few technologies out there that support this now. And whatever technologies or runtime you choose, I think it's just important to have such a fast feedback loop of basically including new stuff, changing code, changing some configuration, and then just having these changes being reflected automatically on the fly. So what I want to show you now is I want to code a little bit more. And especially, I want to show you the combination of Jakarta and MicroProfile, because I think in modern EE, that is another best practice to just mix and match from these standards, and then include things like, MicroProfile health or MicroProfile config, because the background from these technologies is very similar. So both are based on enterprise Java, and the programming model is very nice and very familiar, right? So we also have a declarative approach of doing things. And what I will show you now, so you see this still works. You can order some coffee again, and then the order is in the system. What I want to do show you now is basically enhancing my project with some more stuff. So for example, I have MicroProfile here, the API, so I can use, the API in my code. Besides that, what I can also do, I can add features on the fly. So I can, for example, say, please add MicroProfile health 2.0, and it will hot reload just this example, and then, install that feature on my runtime while I'm coding, while this is running. So you saw there's something happening here. And then just very quickly, the application is being restarted. And now, apparently, I also can access this resource that you might know if you have checked out MicroProfile /health, which is a default resource that just says, okay, it's up. That is the default resource with HTTP 200. Okay. Well, that's not quite enough. I actually want to see whether my application is up and running. So for example, I call this health. And then what I do, it implements a health check from MicroProfile. That's the way how to write this. And then I implement just this call that could check for, whatever I would like to have here. Named, I call this coffee shop. It's up and built this. So it will include a default check. For this example, I define this as readiness probe and application scope CDI bean. And now the interesting news is just this will be updated on the fly very, very quickly. And I see now this check being up there. And whatever technology you use, right? So this is Liberty with MicroProfile health check, but whatever. The point is, as a developer, you want to be sure that your turnaround cycle is very, very short, that immediately you see some update, right? So I can code some more stuff here. I say, okay, for example, include some data, say, hello world, whatever you want to do, and then just very quickly update that, and then you have it right here. So for me, I have, like, when I'm programming, I have a rule, like how fast my technology or whatever I'm doing reacts, and I call this the coffee rule. So for example, if I change something here, from hello world to goodbye world, and then if I do some action or I wait for something, I want to take, my cup of coffee, I take a sip, I place it back down, and then it needs to be finished, right? If it takes longer than that, it's too slow. So if, you build your project, if you fire up your test suite, if you do whatever, if you wait for the reload, it needs to be faster than that, ideally immediately, right? So I think that is crucial in order to, just stay productive. Because what happens, we are humans and we just get easily distracted, right? So even if we have to wait just more than 5 seconds even, we get distracted, right? So I have to wait, and then what happens? I check Slack, I check social media, I take my smartphone, right? And then you're out of the flow experience. So you just want to stay in the flow and make sure that is being updated quickly, right? Or whatever you do, you get a fast feedback. Now, let me show another thing, MicroProfile config. Let's do this, 1.3. So MicroProfile config is just another MicroProfile technology where I can have some injectable configuration. So if you're into EE and CDI, you might say, well, you can do the same with CDI producers. Yeah, that's totally true. But you can also just use this technology and then save this class and few lines of code by just using this qualifier at config property, where I can just inject, for example, the version of your application, and then say, instead of this, I just want to emit the version here. And then my application version will be, once that is updated, hello, yes, need to be waited for the autosave from the IDE. And then you see, now include the application version, which is 1.2.3. Okay, now you might ask yourself, where does this version come from? Well, there are a few default config sources in MicroProfile config. So for example, property files is one. There is a default convention location, microprofile-config.properties, where I can just include that. And then, that is being configured. Another one is environment variables, where you could actually override this. So this is very helpful for containerized environments, right? And another good news of this update plugin approach is if you update the properties file, what I just did from 1 to 3 to 1 to 4, then this change will also be immediately reflected. Because again, this is a convention path, so the profile knows about this path, and this is just being updated. So whatever you update here in your code, whether it's Java code, whether it's configuration, whether it's a POM XML dependency or a runtime feature, all of that I want to see reflected immediately, right? So let's do a little bit of more of live code with this config, because this is just a static configuration where I say, okay, the string here is always the same with declarative lookup, but I can also do a programmatic lookup by injecting this config. And in order to do that, let me implement another feature. Let's say the coffee orders here, as you can see, also have a price attached to it. By the way, in real world, never do money calculations with floating point numbers, right? Only an example. Don't do this at home. But I want to add some pricing information here as well. And of course, I don't want the user to set the price, but this should be configured, well, depending on the drink type, right? Like, an espresso is a little bit cheaper than a latte and things like that. So let's say this is another feature, this is another business logic that I want to include here. So in order to do this, let's say I want to add some price, let's say some price calculator. Let's write this. And then in my coffee shop, I, well, of course, want to inject the price calculator here, right? And then, well, I want to calculate some price. So for example, I want to say, well, in order to set the price, I want to calculate the price here. For example, where is method? No. For example, calculate price for a coffee order, and then this is not void but double for a given, for example, coffee order. And then say, okay, now for this order, it depends on the price, how expensive it is, right? So order, it depends on the type, how expensive it is. And then say, do something like get configured price, right? So look up the configured price for this coffee order. And now how do we look that up? Well, basically we can go to the config provider and manually look up this config of my MicroProfile config here, and then say, okay, now programmatically, please get this value of, well, let's have a look here, of the coffee prices. So coffee prices dot something. So let's do this, coffee prices dot, and then, well, whatever is being sent here. So type name and also to lowercase. Well, it's not really readable. Let's outsource this into a variable. And now we want to have this as a double type, right? So that should be injected or looked up as a double, and then this hopefully will be configured here, right? So by the way, I can just keep coding here what I just did, and then it will recompile and maybe fail because of compilation errors and things like that. But it doesn't matter. I can just continue doing this, and once the compilation will be successful again, and then I say, okay, now this should work, and then I can calculate the price by using this injected price calculator, and then hopefully we can, well, try this out again. So let's try this out. I will post another coffee. I will order another espresso, and now I want to see that actually my coffee here, let's use this URL, that my coffee now has a price attached to it. Yes, this looks good. So whether you think that's cheap or not depends, I guess, where you live. Let's assume that is in euros. And now for the espresso, it was so and so expensive, right? Let's try this out again with another drink. Let's say this is a latte. So now in this case, I want to check whether this price is being reflected correctly as well. And yes, 3 euros here. So this works. So depending on the type, we can have a programmatic lookup here for MicroProfile as well. So as you just see, this is a very nice development workflow by just keeping, in this flow mode, by just changing something, seeing the changes being reflected, and so on and so forth. So for me, that is another best practice, to just keep these turnarounds cycles short. And well, it's not just about testing something manually, what I just did, I ordered some new coffee and I checked it. No, the same is true actually for your proper tests that you run. So let's talk a little bit about testing here. I have some tests being included here, and this is just very, very basic. For example, I include some basic unit tests that uses JUnit 5 parameterized tests. So as you saw in my project, this is just the, well, I would say test technology that's used in most of the projects that I see. JUnit, nowadays JUnit 5 with Mockito and ideally assert.j. I like the assertion, the readable APIs of assert.j here. And we can just, write very basic tests. So the topic of testing is a more bigger one and a complex one. In general, what I really, really care is that the whole test suite runs just very quickly. And I mean, instantly. So if you have a more complex project, then, you might have hundreds of test classes and they need to run with less than a second. If you have plain JUnit with the JUnit runner, you can literally run hundreds of tests in a few milliseconds. JUnit is very performant and very fast if you do this in a code level. And in general, I just want my test suite to run quickly. Now, for code level tests, you can achieve that. The most important thing is that you, as much as possible, avoid test runners that try to start up the whole world. So, for example, if you start embedded containers, things like if you're in the Spring world, Spring context test, things like Achillion, things like CDI unit. So there's a reason why I'm not a big fan of these technologies. The TLDR for that is, well, it typically adds a lot to your test runtime. So they typically run slowly. You don't see this impact immediately. You see it only in more complex projects once you have many, many of these tests. And this is how you end up with build times, in minutes and more. And ultimately, if we are in a modern, microservice world with distributed systems where we have a lot of communication between systems going on, then it's actually more and more important that you test the end-to-end integration example of how your services interact with each other, of whether this communication works as expected, right? And for that, it's not enough to just have simulated tests that fire up some simulated environment, but to run the test against the actual running environment, or the same environment that would later on run in production. So for example, if you run your application in Docker containers, it's crucial that you test the Docker containers from the same Docker images that you test, for example, locally, or that you test in your CI/CD pipeline, and so on and so forth, in order to reflect the correct examples here. So in order to do that, let me show another test that I have. I call this IT for integration test. So that is Coffee Shop IT. That's another Maven best practice. If we call our tests something test, T-E-S-T, that will be executed by Maven Surefire out of the box. And if we call it IT for integration test, then it won't be executed for Maven Surefire. It will not be included in Maven package or one of these phases, but only if you explicitly run the ITs. So if you configure something in your POM XML where you manually exclude some patterns, that's actually not necessary. You can just use the convention and that will work as expected as well. So what I have here with this IT, I basically want to test, this is a very basic smoke test, whether my application is up and running. So that should be a test with a more end-to-end scope, where I connect against my actual running application and just, test this out. I could connect to it and then, create some coffee orders, then connect to it again and verify whether the order is in the system correctly and all these things. If you're interested in that, I can point you to some more resources that I produced on the topic of testing. But just in general, the point here is you want fast feedback on also that end-to-end test level, right? So if you change some code, you want to be sure that also, the proper production code that, for example, emits your HTTP resources and your JSON works as expected. So in other words, you quickly want to fire up these end-to-end system tests, integration tests, against your locally running environment to just quickly verify that. And with the approach that I showed you, this is actually possible. So for example, if I say, well, I have this application, and another nice feature of this plugin here is if you hit enter, then it will just run your tests. And first of all, it will run the Surefire unit tests. So it runs this test, which runs very quickly. And then it will also fire up the ITs, the integration tests. So my typical Maven build doesn't do this, but now I see, okay, assertion failed. Why? Because, well, I reconfigured this before. So I say, check that the system is up. So this means, well, check the health check resource of MicroProfile health and see whether that's up and running. And then also get the application version that I included and check whether it's equal to 123. Well, you noticed we didn't do this here. We changed it to 124. So now let me actually change it and run the tests again. And now everything is green. So what this test does, it's basically a very simple HTTP client that connects to my locally running application and says, localhost 9080, please connect in this case to health, check for is system up, whether the system is actually up and running, or here get the application version that is included in my health check response, just for me, right? I could change this system driver here to say, please create a coffee order, and then it will post, this and that to this URL. Now get the order for the following ID, and so on and so forth. So again, by doing this approach, I can just run this test very, very quickly because it's plain, it's JUnit still. I don't fire up anything that is running here, but I can just connect to something that is already up and running. I can, of course, run the same test in my IDE, whatever you prefer here, or I can even run it from command line. In either way, it's just very fast and very, productive. So for example, if I would like to run this on the command line, I say Maven fail-safe integration test. So this is the way how to manually and explicitly run the ITs and not the Surefire tests actually. So you will see, okay, this runs the integration test, and now this runs the same thing, connects to localhost and checks my application that is running locally. So again, I want this quick verification. So let's try this again. If I say, for example, I have my property file, I want to change, let's change this back here. I want to change this in this regard. And then what I do, I can run these tests again, and then this needs to fail, right? And then I can again check either my test or change my test or change the application properties, whatever you want to have, and then just quickly have this verification. So again, instant verification. That is important in order to stay in the development flow. For the tests, what else is important to achieve that? And typically, I care a lot about this, is that you separate the test life cycles from the test environment life cycle. Why? I think this is the easiest way to manage. So I know there are a lot of fans out there for complicated test frameworks where I can fire up a lot of stuff using Java APIs. And while this might be handy on the Java side in order to create, for example, Docker containers and fire them up in my test, the issue I always have, if you annotate some, JUnit 5 extension or some test runner for JUnit 4, then you always make the lifecycle more complicated and you bundle these life cycles together. So one test class then typically, wants to fire up a test environment and does so, and thus it runs, much slower because then, once you start the environment, it just begins to start something up. Or sometimes, but unfortunately not always, it checks whether something is already running and keeps it running, so then it will be faster. But then again, for me, it's actually harder or more cumbersome to configure and manage all these things here in this test class, rather than I would like to separate the life cycles. And for me, it's still easier to run, my environment either, using Maven or using some shell scripts if you want, using plain Docker run, using Docker compose. You can do the same things if you have an external system or a mock server running locally, or a database using Postgres, running locally using Docker. That's actually easier to manage, and it's simple. You just run a shell script with Docker run 3 times, or Docker compose if you want, or even a Kubernetes cluster locally if you want, right? But start it up first and separate it from the lifecycle of the test, because once I am in the development flow, I just want to fire up my test and I want instant verification whether it works, and not wait for even 5 seconds until that is up and running. So for me, that's the important thing here. Now, we have some tests already. So another, best practice, have a proper test coverage for code level tests, such as my unit test, have a proper coverage for end-to-end level tests. This might be included in the project, or once it becomes more complex, you might have a dedicated system test project, maybe under the same repository, where you literally connect against, a running application and fire then up some proper use case tests and proper acceptance tests, whether your application does the expected things. And this test suite might already fire up a few more containers, a few more applications, depending what you do in this regard. All right. I can show you a little bit more of MicroProfile technology if you like. So for example, what we have, let's go back to this runtime thing. Again, all of that is included in these APIs that I just have. MicroProfile, that's the umbrella one. So it includes, health, config, a few other things. Let's say I want MicroProfile metrics. That's another cool one as well. So this, from my experience, this really adds value to Jakarta when you say, okay, you don't have to implement, for example, MicroProfile metrics with the Prometheus monitoring format yourself, but you can just do this automatically, or not automatically, but using these APIs, and you don't have to implement it yourself. So let's try this again. When I go to localhost metrics, so /metrics, that's the default metrics URI, then, well, first of all, Liberty will tell me that needs to be accessed using, SSL, because you actually need to authenticate and so on and so forth. But actually, I don't care in this place, MicroProfile metrics, because typically you would like to, see some user, a name and password and so on and so forth. And now I say, oh, I don't care in this test example, just set the authentication to false. And again, I can reconfigure stuff here on the fly. And now what you see, this is the cryptical response of a Prometheus format. This is a plain text line-based format of having, some metrics like per default, some runtime information such as JVM information, memory, CPU, threading, garbage collection, and all kinds of stuff. What that already might be interesting for technical terms if you want to monitor your application, or what is also interesting more interesting if you include some business metrics, right? So for example, questions that the business care about. So how many coffees have been ordered? How much revenue we made by selling so and so many espressos and cappuccinos and whatnot. So that is a little bit more interesting to include APIs or include some metrics on a programmatic API level, saying, oh, for example, we could inject some metrics here and then manually increase, some counters. We have some gauges, histograms, and depending on what you want to do. Or there's another simple way, for example, a declarative approach, again, of just counting actually method invocations. So that's the probably easiest way, saying, okay, this should be coffees total. So the total number of coffees, for example. And this is just a very basic counter that works here on this method. And then, well, let me restart this again. If, for example, I post some new, let's do a latte, why not, to the system, 1, 2, 3 times. And now I go back to my metrics page, then I see another metric being included here. And this is now a business related metric for total number of coffees, 3. And then how that works is my application just emits that method, and then a Prometheus instance would scrape this method from this very page, and then store it in its time series database, and then you can have some fancy Grafana dashboards and things like that to display it. Again, the nice story is if you use this combination of Jakarta and MicroProfile metrics, then it's very easy to implement. You don't have to write all of these formats yourself. You can just configure the runtime to include it, have some a little bit of code here, what you want to do programmatically, and you're done. That's basically it. Now, let's continue a little bit more on how to run our project in a more production-like setting. So what I want to show you more is on the deployment side. We already covered Docker. So we have a Docker image of our application here. What else you probably have in your project is, well, some more sophisticated way to run containers. So typically we have some kind of container orchestration nowadays. For example, you use Kubernetes, similar things, maybe Docker Compose. What I want to show you is a Kubernetes example. So I have kubectl. I have a Kubernetes cluster that actually runs on the cloud. So where you get Kubernetes clusters from, well, there are many, many ways. For example, you can install it locally. You can have Minikube or Minishift if you want. You can have a managed Kubernetes service. This is typically what I use. So I use the IBM Cloud for managed Kubernetes. You can also have a managed OpenShift cluster if you want. And well, this runs actually here, not on my laptop, but on the cloud, but doesn't matter. And actually, let me do this again. Let me delete the resources again, just to show you the full example, because now what I deploy is just this way of deploying a service and, so-called deployment. So basically say, take this Docker image and deploy it, create what is called a pod with one replica, so one pod, one running instance, and deploy it, make it accessible via load balancer, so-called service, for this coffee shop application, and just deploy it. The nice story about this technology is you have what is called infrastructure as code. So same, as a Docker file, that's also infrastructure as code. You define as code how the runtime is supposed to look like. So these are the steps for an individual running container. Or in this way, how the whole environment looks like, right? So how does your test environment, production environment look like? Well, exactly like this. You say you want to fire up one instance of this running container, check the health here using this readiness probe, and so on and so forth. Or if you want 2, 3, 10 replicas, that also works. You just change the declarative approach of specifying it here, and then the technology will make sure that this is the case. And of course, this is so much more productive than calling support and ordering another server that needs to be installed physically, and then installing, Java, the runtime, and so on and so forth, some configuration. So now in this world, we just run our containers, and then this works here. So now this is empty, this cluster. kubectl get pods, there's no running application. So let's change this. We kubectl apply everything that's in this folder. So we apply our nice YAML files to basically create this. So then it will just start up the application, this coffee shop here. We will have a service being available, what you just saw before, and then it starts up this application, we can access it. So this looks good. Let's try this out once. My application is up and running and ready to do some meaningful work. Again, we use MicroProfile health check to check this. Then I can actually access it. So let's do this. Let's order some coffee on the cloud. I have a magic script that gets me the IP address of my public cluster. Then I say, for example, coffee shop, or let's check the health first if you want. And now, okay, that's good. Now that is up and running. And I see, version 1, 2, 3, and so on and so forth. And I can even, order some coffee, right? So same URL again. I say orders. Now, please, post some, let's do some latte again here to this URL. And then nice, 201 created. This works. And now I can go back and check my coffee orders, and there it is. So that's a nice story. I can order some coffee here. And another thing that I want to show you for the testing approach, what I talked about before. So I showed you this test with a very simple way to run it. And now what I can do, I can actually reuse either these tests or the components here to actually test against the other environment. So now I have my application running here in Kubernetes. So I say, oh, by the way, why not just, instead of localhost, point this to my Kubernetes cluster and run the same test. And this is actually what you can do if you separate the test lifecycle from the test environment lifecycle, because now my test is independent. It can just, connect to any environment that runs my application here and verify, whatever I want to verify. So for example, verify whether it's up and running here. So in this regard, how I can run it, either in the IDE or here using Maven, I say, by the way, I have a system property, coffee shop test.host. So I set this just to my cluster IP. And then I say, well, I also have coffee shop test.port. I say set this to 80. That's my gateway here. And then I can just run this against now my Kubernetes cluster, the application that runs there. And so that works. Okay. Actually, never trust a test that is only being green. Let's say maybe that still runs the local host version, who knows? So let's misconfigure the port here. And then after a few seconds, we hopefully run into a timeout because that is the wrong connection and says, okay, now this doesn't work. So it actually will test the application that runs in my cluster. And that's why I can reuse these tests. So that is another, nicer way to make your tests a little bit more effective. So I can reuse the efforts that I put into these tests here and recycle them. Another important thing, what I always want to mention, if you look into my material that I have for testing, you will see this as well, but I really care that for the tests you write, you implement at least some proper code quality, even if this is just test and just the test scope, but it will make your tests much, much more maintainable. So for example, in this test class, I only say, well, assert that coffee shop system is system up, or get the application version equals to something else. How you get the application version is now implemented by a delegate, by this test driver. It's even more obvious if you say, okay, how do I create a coffee order and how do I verify that the order is in the system? You don't want to leak some lower level HTTP or JSON detail here in this test class, because otherwise what happens if you have hundreds of test classes at the end, or test methods, well, then if something changes, you're screwed. You have to throw away or maintain a lot of test classes. What you can do here, you just change the lower abstraction, how it is implemented to, for example, get the application version, and then just change the code here, and you don't have to modify all of your test classes. So this is very, very important in general, just to keep your tests more maintainable. So same is true for test data. Just care about these abstraction layers, in which abstraction layer you're currently in, and when it makes sense to implement something here. So that is basically it, how we can run our best practice project now in a Kubernetes example. So for Kubernetes or containerized applications, maybe you've heard of the 12-factor principles that basically is applied, or that is sufficient if you run a workload in this way by a containerized approach. You could reconfigure things here, and you can rebuild your application very, very quickly. So for example, assuming this approach is not enough for the dependencies that you have. Let's stop now my running workload here again. You want to include, for example, or you need to include another dependency. I always highlight this because in my opinion, this is sufficient for most of the projects here, depending what you do. Sometimes you do have some other dependencies either on your runtime or in your code where you just need some more stuff. So for example, if your business use case is to do some image processing, then of course it makes sense to include, the API, the dependency for this image processing. So this is a real use case requirement of some dependencies that you add. But still, what you should do in order to make your build stay productive, you should add them as a provided dependency to not, clutter up your deployment artifact. And then in your runtime, so for example, that is configured here in your Docker file, what you do, you add this dependency, this jar, for example, in a lower Docker image layer, because these, all of these lines, all of these commands result in individual Docker image layers. This is how Docker images work with the so-called copy on write file system. And then what you do, for example, let's add, just as an example, a Postgres driver for a database. This would be a dependency that you don't even use in the POM XML, but only in the runtime. Then I don't want to include this into my WAR file because, that just adds a lot of weight, a lot of balance. But I say, please add this in a lower level detail and a lower level image. And then, just have this included to the libraries. Same is true for other jars if you want. And still you maintain these layers, right? So for example, you noticed this when building. When I had my Docker build before, you noticed I had this these layers. So now that is being updated as well. But still, if I change my application, for example, if I rebuild this using Maven package, then only what it does, if I rebuild it here, not this, if I Docker rebuild this here, then it will not change the other layers. That's only cache, and it will only actually execute the last step. It's even more interesting. So this is just the build time of saving maybe a few seconds. It's much more of an impact if we actually, push something over the wire. So for example, if we say do a Docker push of, let's rebuild this in another name. I call this Sebastian Dashner, so I can actually push it to a public Docker repository. And if I say, okay, now I want to Docker push this, what it does, it analyzes the image and it sees, oh, actually only the last layer has been changed. So I literally just push whatever, the last layer contains, which in my case is a tiny WAR file of, a few kilobyte. And then it only pushes a few kilobyte, and regardless how the actual image, how big the image is, it doesn't push all of it. And I used, I kid you not, I used mobile tethering. I used airplane Wi-Fi before to push and pull Docker images, because if you use this approach, it's literally just a few kilobytes that you transfer over the wire, and you don't repush over and over again implementations that should be on a different level. And I think this just makes a lot of sense to consider. And it matches really well with the idea that was always implemented by Enterprise Java of having these thin deployment artifacts, of putting the logic, your code, your use cases into your code, into the deployment artifact that you ship, and put the implementation into a different layer. That typically is, the runtime or application server, or however you want to call it. They implement how to do, HTTP handling, how to do database transactions. And it also fits very well these abstractions that we now have in a containerized world of cloud native technology. For example, if you run it in Kubernetes, then this will implement how to do the service lookup, all the service load balancing, how to do the networking connection. If you have service meshes with Istio and other things, then you implement, how to do mutual TLS, for example, or how to do the metrics scraping on a more manageable scale, right? So you don't clutter up all of these details. You don't clutter your code with all of these details because your artifact, does not need to include that. That's not a concern of the Java code you write. So keep the Java code clean for the business logic. And I think this makes your project more maintainable, and especially the builds more efficient. So as some key takeaways, what I care about that you use known technology and APIs. I think this is the most or one of the biggest advantages that you have with Jakarta, that you also have with MicroProfile. You have APIs that are known to a lot of developers, such as CDI, JAX-RS, that is typically nothing new. And focus on what solves a business problem for you, right? So in the project that I write, I want to focus on what I actually do, right? Create coffee, so for example, right? Not implementing some other lower level technical details. Then I think the combination of Jakarta and MicroProfile is awesome and is a very productive one to create modern applications, especially if you use MicroProfile. The projects do basically fill the gaps that we still have in Jakarta that comes from Java EE, right? So for example, injectable configuration, health checks, metrics, fault tolerance, and a few other things. I think that's just very productive. And this technology is also very interesting if you have projects with existing investment in EE, right? So if, especially the knowledge investment, if the developers know these APIs, CDI, JAX-RS, it just makes sense to use a modern approach with modern runtimes. So for example, OpenLiberty or Quarkus or Payara, or all of these modern runtimes that are really efficient and fast. Then this is just a very efficient approach, I guess. Then keep the whole build and the whole tool usage simple, and use the tools, how they're good for, what they're made for. So for example, Maven to build Java artifacts, Docker to build Docker images. In my eyes, this just makes sense and is the most efficient approach. And this is what I use in projects, and this is what just works really well, I think, and use and leverage these build-to conventions. So for example, Maven conventions of naming and things like that, so you don't have to reconfigure or configure stuff. Use the Docker best practices with the copy and write file systems, same with the Kubernetes and these principles, and this just make it very, very efficient. And then very important to stay in this development workflow of the flow experience of developers, to keep your turnaround time short. And I mean really short, as in less than a second ideally, or less than 5 seconds. Otherwise you will get distracted and it's just way too annoying. And there are a lot of tools out there for all kinds of technologies actually to achieve that. You might use this Open Liberty development mode. Quarkus has a similar mode. Spring DevTools, I never used it myself, but apparently can do the same thing of this hot reload approach. Take care how you craft your tests and your test scopes so that they execute really, really quickly, that you can just stay in a mode where you develop something locally, even if it involves, external systems or mocked systems, databases, and then just code something, change something, and verify it. And also verify it on a test level. And this will make you very, very productive. And other than that, have some investment in testing in general, automation also, as we saw, and some proper CI/CD approach. So regardless of this development workflow that you can build up, always also have a proper CI/CD pipeline that builds a project, builds your images, Docker images if you use that, and verifies that on a production-like environment from beginning to end, regardless of what you do locally. That locally is just an optimization to be more efficient, but then to verify that it works properly until you deploy to production as well. And I think if you use these approaches, you will just be very efficient with modern enterprise Java. And from my experience, it's also a lot of fun to use these technologies. So I hope this was helpful. Thank you very much for watching and for listening. And if you're interested in a few of the materials that I pointed you to, you can have a look at this GitHub example and some other materials there, some thoughts on testing in order to be a little bit more productive as an enterprise Java developer. Thank you.
Okay, great, Sebastian. Thank you so much. So let's see if we have any questions in the chat.
Please.
Should Jenkins or other CI/CD build Docker container from Docker file and deploy app on it in time of a single task?
See this question of whether it's a single task or how you exactly implement it. I would say it depends. I've seen multiple approaches that mostly depending on the actual environment that you have. So where Jenkins runs. So for example, if Jenkins also runs in a Docker container, then you can actually build Docker containers inside of Docker containers, but then typically you use another approach to build these images. So for example, like Scaffold, or use some other technology, or OpenShift builds to build the images. That is more like a detail, I would say, whatever makes sense for your environment. But in general, just have a proper sophisticated CI/CD pipeline that builds this. Ideally using the same approach that you could do locally, but that's not a requirement. I hope this helps. Some other questions. Yes, Server XML is Open Liberty specific. Okay, do we have some more questions?
I don't see any more questions, but yeah, if there are any questions out there, now is the good time. Everyone is impressed, as always, Sebastian. Thank you very much. So we're looking forward to another opportunity to have Sebastian back with the Jakarta Tech Talks. But in the meanwhile, let's wrap it up. And again, many thanks. And we'll talk again in the new year already.
Awesome. Thank you very much.
Thank you. Bye for now.
Bye-bye.